Welcome to another deep dive. Today, we're going to be exploring something that's seriously bizarre. We're talking quantum foam.
It's a concept that really challenges everything we think we know about the universe, about reality itself.
Yeah, I mean, we're talking about the very fabric of the universe, but at a scale that's almost impossible to grasp. So can you help us wrap our minds around this?
Imagine if you could zoom in way beyond atoms, way beyond even the particles inside atoms to a scale a billion times smaller than a proton.
Okay, so we're already in crazy territory here.
That's the realm of quantum foam.
So what happens to space-time at this mind-bogglingly small scale?
It becomes incredibly dynamic, constantly fluctuating, bubbling and churning like a stormy sea. Instead of that smooth, predictable space-time we experience, it's more like a chaotic frenzy of activity.
Wow, so it's not the static backdrop that we imagine as constantly moving and changing.
Exactly. And at the heart of this dynamic behavior is the Heisenberg Uncertainty Principle.
Ah, the uncertainty principle, always a favorite in quantum mechanics. Can you remind us how that plays into all of this?
You got it. So the uncertainty principle basically states that the more precisely you try to measure a particle's position, the less you can know about its momentum and vice versa.
So the smaller the scale, the more uncertain things become.
Exactly. And at the Planck scale, where quantum foam exists, this uncertainty becomes so extreme that space-time itself starts to fluctuate wildly, borrowing and lending energy from the vacuum.
This constant borrowing and lending of energy, is that even allowed? Is the universe just making it up as it goes along?
Well, in a way it is. The universe can take out tiny loans of energy, creating these virtual particles that pop into existence for an incredibly short time and then disappear.
So they're like these phantom particles that just blink in and out of existence.
Okay, you could think of it that way. They're called virtual particles, but their effects are very real.
So these virtual particles, are they just theoretical or do they actually have an impact on the universe?
Oh, they have a profound impact, actually. One example is at the edge of a black hole, where gravity is so intense it warps space-time.
So even the universe's most powerful force, a black hole's gravity, can't escape the jittery influence of quantum foam.
Exactly. The fluctuations of quantum foam are thought to explain Hawking radiation.
Hawking radiation.
Which is the faint glow of particles that appear to be escaping from the grip of a black hole.
Wow, that's pretty powerful for something so tiny. And this leads us to one of the most intriguing aspects of quantum foam, the multiverse.
Ah, yes. The idea that there might be countless other universes existing alongside our own.
Okay, so I've heard about this, but I've always struggled to picture how different universes could actually connect.
Imagine space-time tearing and reconnecting at the Planck scale. Those tears leading to entirely separate universes.
Like punctures in a giant cosmic fabric.
Exactly. And quantum foam provides the mechanism for these tears to occur.
So our universe could just be one puddle in a vast sea of other universes.
It's a mind-boggling idea. And while it's still highly speculative, quantum foam does provide a potential mechanism for how such a thing could occur.
It makes you wonder what's out there in those other universes.
Okay, let's shift gears for a moment. We've been talking about the universe on these grand scales, but what about the laws of physics themselves? How does quantum foam affect our understanding of how the universe works at its most fundamental level?
That's where we run into a major conflict in modern physics, a conflict between quantum mechanics and general relativity. These are two of our most successful theories, but they clash at the Planck scale.
You're talking about the clash of the titans here. Quantum mechanics explaining the world of the very small and general relativity explaining the world of the very large.
Exactly. And quantum foam sits right at the intersection of these two worlds.
So are you saying that quantum foam could hold the key to resolving this conflict? To finally unifying these two theories into a single theory of everything? That's the hope. Understanding quantum foam could be the bridge that connects the quantum world to the world of gravity and space-time, fulfilling Einstein's dream.
Okay, that would be pretty groundbreaking. But if quantum foam is this elusive, how can we study it? What clues do we have that it's even real?
One intriguing hint comes from quantum entanglement.
That spooky action at a distance.
Exactly. Where particles seem to be connected no matter how far apart they are.
Entanglement always blows my mind. How does that tie into quantum foam?
Imagine that the interconnectedness of quantum foam allows for this instant communication between entangled particles.
Like they're sharing information through some secret cosmic network.
Exactly. It's as if the fabric of space-time itself is facilitating this connection.
So we're talking about a possible link between the weirdness of quantum foam and the weirdness of entanglement.
Right. And there's another possible clue. Scientists are developing incredibly sensitive experiments using atomic clocks.
Atomic clocks?
Yeah, these clocks can detect tiny variations in the flow of time.
How do they do that?
Well, they're incredibly precise. They can measure time to an accuracy of less than 1 second in billions of years.
Wow, that's mind-blowing. So how do these atomic clocks help us study quantum foam?
If spacetime is foamy at the Planck scale, it could create tiny fluctuations in the flow of time. And these atomic clocks might be sensitive enough to detect these fluctuations.
So we might be able to actually measure time warps caused by quantum foam.
It's a possibility.
Yeah.
And it would be a huge breakthrough in our understanding of this bizarre realm.
It sounds like we're on the verge of uncovering some pretty incredible secrets about the universe.
Absolutely. Quantum foam is a frontier of knowledge, and what we discover could revolutionize our understanding of reality.
All right, before we get too far ahead of ourselves, let's step back and consider what it all means for us. If we live in a universe built on this foundation of uncertainty, this constantly fluctuating quantum foam, how should that change our view of the world?
That's a great question. I think it invites us to embrace the unknown and accept that our reality is far less fixed than we might think.
So instead of clinging to certainty, we should embrace the potential for change, for growth, for unexpected turns.
Exactly. Quantum foam is a reminder that the universe is a dynamic, ever-evolving place.
It's a pretty radical shift in perspective.
It is.
Yeah.
And it's a shift that quantum foam forces us to confront.
This is all incredibly fascinating, but before we dive even deeper into the implications of this strange realm, let's take a moment to process what we've learned so far. Are you still with us out there? Because things are about to get even weirder. Stay tuned.
Welcome back. And I hope that gave you a chance to, process everything we've talked about so far, because we're about to plunge even deeper into the world of quantum foam.
Okay, so before we went to that little break, we were getting pretty deep into how quantum foam challenges our understanding of reality. It's almost like it's this hidden engine driving everything.
Yeah, that's a great way to put it. And one of the most mind-boggling possibilities is that it might underpin us as well.
Hold on. Are you saying that our thoughts, our emotions, even our consciousness could all trace back to quantum foam? That's a pretty big leap.
It is a radical idea, but some physicists are seriously considering it. Think about it. If quantum foam underpins space-time, and we exist within space-time, then it's not so crazy to think it could influence us on a very fundamental level.
All right, but how could something so small, so seemingly chaotic, give rise to something as complex as consciousness?
It's definitely a puzzle, and we're far from having all the pieces. But one way to approach it is to consider the role of quantum processes in biological systems. We're already seeing evidence that quantum phenomena might play a role in brain function.
So you're saying our brains might be doing quantum computations? Is that how we think?
It's a fascinating possibility. Some researchers believe that the complex network of neurons in our brains might actually utilize quantum effects to process information.
Okay, now we're really down the rabbit hole. But if our brains are tapping into the quantum realm, does that mean quantum foam is somehow influencing our thoughts and actions? What does that even mean for free will?
Yeah, that's a huge philosophical question. If quantum foam introduces a level of fundamental randomness into the universe, it really makes you wonder, are our choices predetermined, or do we genuinely have agency?
Whoa, that's a lot to unpack. We're talking about potentially rewriting our understanding of free will, all because of this strange quantum foam.
Yeah, it's just one of the many philosophical rabbit holes quantum foam leads us down. It really makes you question everything you thought you knew about reality.
It's incredible how we started with this tiny, bizarre concept and ended up talking about the nature of consciousness and free will.
Yeah, it's a testament to how interconnected everything is, from the smallest scales to the largest, and it speaks to how much we still don't know about the universe and our place within it.
Speaking of things we don't know, how do we even begin to study something as elusive as quantum foam? What are the next steps in this exploration?
It requires us to really push the boundaries of our scientific capabilities. We need to develop new theoretical frameworks and come up with creative new experiments.
So it's a call for more research, more deep dives into the unknown.
Absolutely. Quantum foam represents a vast, uncharted territory of knowledge. There are so many questions waiting to be answered.
Okay, let's shift gears a bit. This has all been incredibly mind-blowing, but does quantum foam have any practical applications? I mean, how does this affect our everyday lives?
That's a great question, and it highlights how interconnected science and technology really are. The pursuit of understanding quantum foam is actually leading to some incredible technological advancements.
Really? Like what?
One of the most exciting areas is quantum computing. These computers exploit the principles of quantum mechanics to perform calculations that are impossible for our current computers.
Oh yeah, quantum computers. I've heard they have the potential to revolutionize everything.
Exactly. And the development of quantum computers has been deeply influenced by our understanding of quantum phenomena, including what we're learning about spacetime at the Planck scale.
So our quest to understand this crazy quantum foam is indirectly helping to create the next generation of supercomputers. That's amazing.
It really is. And these computers could help us solve some of humanity's biggest challenges, like climate change and developing new medicines.
That's incredible. What other practical applications have come out of studying quantum foam?
Another area is in the development of ultra-precise sensors and measurement devices. Remember those atomic clocks we talked about earlier? The ones that could detect fluctuations in time caused by quantum foam.
Yeah, those were pretty wild.
Well, those atomic clocks, along with other sensitive instruments, are being used for all sorts of things, from GPS navigation to detecting gravitational waves.
Wow. It's amazing how our attempts to understand something so small are leading to tools that can measure some of the largest phenomena in the universe.
Yeah, it's a beautiful example of how fundamental research can have unforeseen but truly transformative consequences.
Okay, so we've established that quantum foam has these big implications for technology. But what about for us as individuals? How does understanding this change the way we see the world?
I think it really challenges us to reconsider what we think we know about reality. It prompts us to question our assumptions about what's real and what's possible.
So it's not just about physics, it's about expanding our awareness. It's almost spiritual in a way.
It's definitely a philosophical shift. Quantum foam is a reminder that we're part of something much larger and more mysterious than we can fully grasp.
And maybe it encourages us to be more open to new ideas, more willing to question what we thought was true.
Absolutely. It's about embracing the unknown and recognizing the limits of our current understanding.
All right, we've covered a lot of ground. We've gone from the bizarre realm of quantum foam to its impact on technology and even our own consciousness, but we're not quite done yet. Stay with us as we explore even more implications of this incredible concept. Welcome back to the final part of our deep dive into the bizarre and fascinating world of quantum foam. We've explored its impact on everything from black holes to our own brains.
It really has been quite a journey. And now I think it's time to tackle one of the biggest questions of all. What does quantum foam tell us about the nature of reality itself?
Okay, let's get philosophical for a moment here. We've established that the universe is far weirder and less certain than we tend to think. But how does knowing about quantum foam change how we view our place in all of this?
Well, imagine this. If space-time is constantly bubbling with possibilities at the quantum level,
Okay.
then our reality might be just one outcome among many.
So like a choose-your-own-adventure book where every quantum fluctuation creates a new branching path, a new possibility.
It's a fascinating way to think about it. Every instant could be a point where the universe could have veered off in a completely different direction.
So there could be countless other versions of ourselves out there living out different lives and different realities. Is there a universe where I'm a rock star or maybe a brain surgeon?
It's a mind-blowing concept. While we can't prove it, quantum foam certainly opens the door to those possibilities. It challenges us to reconsider the very idea of a fixed, singular reality.
Okay, my brain is officially melting. But let's say, for argument's sake, that the multiverse is real and there are infinite versions of ourselves out there. What does that mean for us here and now? How should we live our lives knowing that reality might be far more fluid and uncertain than we ever imagined?
I think it invites us to embrace the mystery and wonder of it all. It tells us that we're part of a universe that's constantly evolving, constantly exploring new possibilities. Instead of clinging to the illusion of certainty, maybe we should be more open to the infinite potential that quantum foam suggests.
So instead of trying to control everything, we should embrace the fluidity, the unexpected turns. It's a pretty big shift in perspective.
Yeah, it is. It encourages us to be more present in this moment, in this reality, while also acknowledging the vastness and the mystery of what lies beyond our perception.
That's beautiful. It also makes you think about our connection to everything else. If everything is ultimately made of this same quantum foam, it really highlights the interconnectedness of the universe, doesn't it?
Absolutely. It's a reminder that we're all part of something much grander than ourselves, From the smallest quantum fluctuations to the largest cosmic structures, we're all participating in this incredible cosmic dance.
Well, I think we've reached the end of our deep dive into the amazing world of quantum foam. It's been a wild ride, to say the least.
It has been. It's been a pleasure exploring this with you, and I hope our listeners are leaving with a sense of awe and wonder.
So as we sign off, let's leave everyone with a final thought to ponder. If quantum foam is the foundation of reality, the source of all this incredible diversity and complexity, what does that tell us about our own potential, our own capacity for creativity and growth? Perhaps the universe is showing us that anything is possible, that the boundaries of reality are far more malleable than we ever dared to imagine. Thanks for joining us on this journey into the heart of quantum foam. Keep exploring, keep questioning, and never lose your sense of wonder.